This is Scott Patrick with Rio Grande, and we're inside STL Auto Edit. The first thing you're going to want to do is go to Settings, Details, and take the check mark out of the first box here. This will allow you to place your parts in locations on your platform build plate other than the center. We click OK on that, and let's open up a file. We'll go to my desktop, and I think I've got a file right here, an STL file. The first thing you'll see is it will say out of the working area. We hit OK to that and go to Edit and Edit To. It's out of the working area because we're only in a viewing area on that. Now we know that these pieces grow upside down, so the first thing we want to do is go to our rotation and rotate that by 180 degrees and hit apply. This will then turn them upside down, and we then want to adjust the base plate position so that they are actually attached to the base plate. So we hit the adjust base plate position and set objects on the base plate. OK. We now have our pieces located properly. It's now time to slice them. We're going to go up here to our show layers, and our layer thickness can be adjusted. Remember, the thinnest layer that you can go is 10 microns, and the thickest is going to be 1/10 of a millimeter. A sweet spot for a lot of these is going to be 0.03. That is the default for most of the resins. Everything else you leave alone. You'll hit start slicing once, and you'll see the number of layers here is going to be 1007. We hit start slicing again, and this will then begin slicing these models into the correct layer thickness that you've chosen. This may just take a minute or two, depends on how many pieces you've actually got on your platform. In this one we've got 3 separate rings, so 1007 layers on 3 rings could take a minute. Alright, we've got our rings all sliced now. If we roll this around, you can actually move this layer bar here and watch how this grow will occur. So at this point, it's time to save the file. This is in fact critical, a little tricky part to work with. We're going to go File and Save Objects As. What we want to do is create a folder for this ring. So we're going to go up in here and either choose this, Create New Folder, or right click and New and Folder. We're going to call this Swirl Test, like so. And we open that folder, and now we're going to save our rings. We started with an STL file, but we're going to save this file as a PRM file. This is the sliced version of the file we started with. So we can hit save on this, and what this is actually doing is, we noticed that we had 1007 layers. This is actually creating 1007 files, one for each layer, plus a placeholder file with the name of the file here. So we've got 1008 files. That's why we're going to put those in a folder by themselves. You don't want to save this on the desktop, or you'll have 1,000 files on your desktop. So we're done with this now. We can go ahead and close it, and we're on to the next software. This software then will be DW File Generator. So the first screen here, Data to Elaborate. This is the source file name that we're going to generate. So we're going to go in and drill down to the file that we saved previously as a PRM file. So here is where we saved that. This type of file is not an SLC, it is in fact PRM, and here's the file we just saved. So we open that up, it comes up in here. Now our hatching, our laser hatching, can be set at any of these numbers, and there's going to be a special hatching layer thickness combination that you're going to want to use. We're running the I'm going to run this in the DC 500, and for this I believe I'm going to go ahead and use a hatching of 4. This may vary. Talk to your technician and we'll see what a good combination would be. We're going to go ahead and save this right back in the same folder that we were working with before, and this is going to save out as an MKR file. So I'm going to name this Swirl Ring MKR, and we'll save that. Now we need to elaborate the data, and this is now going to put your layers and your laser hatching information together. We'll begin seeing a simulation over here that will grow these files. Notice that the direction of these lines shows the direction of the hatching, and so it does a crosshatch, which creates a very strong, very detailed build. This will give you your time, your remaining time, and your layers will be shown up here. And as you can tell here, we've got layer 29 or 30 of 1007. So give this a minute and we'll have our layering done. Our digital wax has generated its file. We hit OK. Now if we want to see how much time this is going to take to grow, we can get an estimation by going to Browse, and we're going to go to our MKR file that we just generated and open it, and now we'll check it. This is going to run through all of the layers and simulate the grow, and we'll come up with a estimated time. There we go. Sometimes the window will pop up behind the front window, but we see here we've got a modeling time of 18 hours and 47 minutes for these 3 pieces. We hit OK here. Remember, a lot of the time is going to depend upon our layer thickness and our hatching. A good combination for the DC 500 oftentimes is a layer thickness of 4 and hatching of 7, and that's going to give us a grow time that's considerably shorter. Once we are done here, we can exit and go on to our controller.